Okay, hi, and welcome to the Inference and Mathematical Biostatistics Boot Camp 2 office hour. Let's see, so it's nice that there's some QA questions on the side here that I'll just jump right into. Okay, so let's, oops, excuse me a second. Yes? I want to do it office hours. Sorry about that. Let's see. So, oops. Let's see. This is a continuation of a previous question. So let me. During homework on hypothesis testing, sometimes I'm confused with the sequences of mean values while calculating the differences of two sample means. And when I'm wondering when I should use new minus old or treated minus placebo. Let me. Okay, so let me answer this question kind of in an elaborate fashion. Let me get my screen share going here. There we go. All right. And so we covered a couple of procedures where we might compare, say, x bar 1 and x bar 2, or say p hat 1 and p hat 2, or where x bar itself might, x bar I, it might be a change itself or something like that. Okay. And if you form, say, for example, a confidence interval, x bar 1 minus x bar 2, say plus or minus z1 minus alpha over 2 times the standard error of x bar 1 minus x bar 2, right? That's a 95% confidence interval, and you'll get, say, A to B. Okay. Now, let's suppose you were to form the confidence interval x bar 2 minus x bar 1, okay, plus or minus z1 minus alpha over 2, standard error hat x bar 2 minus x bar 1. Okay. It turns out that you'll get, of course, the same interval, but now the larger number will be negative b to negative a, where these numbers themselves might be negative, so it's just flipping them. Okay. And so the point being that the intervals actually agree, will always agree. If here's 0 and here's your interval where you've subtracted treated minus placebo, right? Then this is saying that this is suggesting that treated has a higher mean than placebo because the interval is entirely above 0. And that if you were instead to do placebo minus treated, you would just get the same interval on the other side, again, still suggesting that treated has a higher mean than placebo. So in other words, that when you subtract them, you get a negative value now. But if you subtract them in that order. This does itself lead to a problem in the auto grading on the quizzes, which I think is what Rui is asking. So in the quizzes, especially in the inference class, now in the boot camp class, I just have people do multiple choice. So if you don't see this answer, take the negative, and then it's that answer, right? So you can eliminate things very easily. Then the opposite, at any rate, so what I do in inference is when I ask this question, I actually specify whether you should do placebo minus treated or treated minus placebo, or say time 2 minus time 1, or so on. And the reason I do that is so that you get the sign right. If you plug in the wrong sign, it's going to be wrong in the auto grading for inference. So it's an important consideration. So I think that's probably where that question is coming from. Okay, so let's see, question 4, and then let me just see here. And remember, for those other folks listening in, to please type your questions into the QA session. Okay, to the QA, which is the little the little text box on the Google Plus page. You should be able to, at any rate, you should be able to see it. And so let's see, continue work out the regarding question 4 and 5 of quiz 1. Let me get those up. I'm gonna check. I'm not sure which of the two classes this is from. So let me first try. Let me first try Boot Camp 2. So question 4 and 5 of quiz 1. Where is it? Module 1. Quiz 1. Continue. Okay, so I think part of the question here is how to actually do this in R. And so let me just bring up RStudio. And see if I can get a different RStudio. Okay. And then here's I'm going to try and grab this. So here in that question it has I'm going to try one more time to copy. So there's the new, and the old is okay. So we, in this case, in this quiz, we want a oh, I think I know what the confusion is. So just to remind you, so these, in this question, the values given in the question are the natural log of the waiting time. So if, for example, you wanted what the actual waiting time in hours was in this particular case, it would have to be that. So it would be 0.17 hours. Obviously, these being negative, they can't be the waiting times themselves. Okay, so first of all, for this question, recognize that the values given, this is question 4 of quiz 1 for Boot Camp 2, the values given are the natural log of the waiting time. So the values themselves were logged. I mean, you know that's right, because if you then were to try and log them, you would get NAs and missing NANs, because you can't take the log of a negative number. Okay. So at any rate, in R, the function t.test will do a t-test of these two groups to determine whether or not the population means that we're assuming these data were drawn from are equal. So if you do t.test, you do it, and it's automatically doing it's automatically doing the unequal variance t-test. So let's see. So in this case, one thing that the question is asking for is a one-sided t-test Okay, so if you do, help t.test, you look over here. Okay, let's see. You maybe can't see it too terribly well over there. Let's see if I can zoom it in a little bit more. That's as much as I can zoom in. It looks like. So the option for having it be one-sided is alternative equals two-sided, less than, or greater than. Okay, so if you were to do t-test kind of alternative equals quote less, you get that guy. Now you might let's just talk about the fact that you don't know which direction of less it's doing, because if we put these guys in a different order, we're going to get a different answer, right? So in this case, the p-value is 0.7 if we do less when we put in old first, and it's 0.26 if we do new first. But look, the mean for new is less than the mean for the old one. And so we want to test whether or not the new one has a lower mean than the old one. In this question, it's asking about waiting time. So what we're hoping for is that the new system has a lower waiting time than the old system. So it's pretty clear that this one, t.test new old alternative equals less, is doing the one that we want, right? Because if the p-value is bigger than 0.5, that means that the actual means themselves are reversed to what your hypothesis would actually suggest. So okay, so any rate, if you were to so any rate, the t.test, this alternative equals less, that gives the answer. And if you do $conf.int, it gives you the confidence interval. Okay. Oh, it's giving infinity for one of the two confidence intervals. That's strange. Why is it giving infinity? That's different than what I'm getting when I did it before. Oh, aha, I know what I did wrong. The other thing that was wrong about this was that these observations are paired. Let's see. In an effort to improve to osmolar, and that was aha. I see. So the observations were paired. Yeah. So I'm seeing from Rui's question what the concern is. So the option should be paired equals true there, and that should be added in. So let me see. Paired. So if we do new minus old, let's see. We should get the same answer. I see. Now I see the question. Y is missing. Yeah, actually, you don't need. If you subtract them, you don't need paired equals true. Yeah, it should give the same answer. See 0.53, 0.53. Now I see the question. I see that there's potentially an error in the quiz itself. So let me double check that. Now I see the question is that the answer on the quiz in Boot Camp 2 question 4 actually doesn't actually, it says let's do a paired t-test and actually doesn't do the paired t-test. So yeah. Yep. Okay. Yeah, so let me double check that and make sure that I do have the correct answer in there. But I don't want to do it real time because you always screw it up if you're doing it real time. But anyway, Rui, I concede the point of what you're trying. I think I understand what you're trying to ask, and let me just double check. whether or not the paired versus unpaired answer being given is correct there in the quiz, and I do thank you for pointing that out. But I hope in the answer to your question, what you're going after is what does the R code actually tell? What is the R code actually doing? And I hope that in the process of going through this, you see what it's doing. So t.test is giving the is performing the t-test. New, old is just the two vectors of that you're trying to test. The difference in the means between the $ grabs the confidence interval, and exp just raises the endpoints of the interval to the e to that power. Okay, so let me, and then I think probably the reason why you're asking this, and maybe potentially the reason why you're getting the wrong answer, is that it's possible that the quiz question is not right. So let me double check that. All right, let's see. So Stephanie asked this question: is the power shown inside slide 5 of lecture supposed to be the same as the power shown inside 11 of the same lecture? Okay, let me find the slides. Well, I am on the wrong version of the class. I want version 2 of this guy. Let me see. Lecture 3, 4. Okay. Slide 5. All right, and then now let me. Okay. Okay, so let's see. Slide 5. Let's see if you just hit T, we want slide 5. Is the power shown in slide 5 of lecture this was the same as power shown in 11? I'm not 100% sure this quite. Let me see if I have. Maybe am I on, Stephanie? I don't know. Maybe if you can double check. Am I on the right slides that you're looking at? Because let's see. Okay. Let's see. Power slide 5. Oh, okay. It was not the. Maybe the title slide is. Why does this not go to? Yeah, if you click on 5, it goes to 7. Interesting. Okay. At any rate, okay. Assume normality and that the sample in question will have a standard deviation of 4. What would be the power if we took a sample size of 16? Okay. All right. So let's see. So this all looks reasonable, and then let me see what slide 11 is saying. So it's not. Yep. Oh, okay. Thanks, Stephanie. It is not technically the same thing because one of them is doing the t-test power, and that one is doing the Gaussian power. Let me just double check. Okay. So here in this case, we have the same number of subjects, so we want an increase and we have 16 subjects, and we want to detect an increase of at least 2 events per hour above 30. So our difference in means 30 minus 32 will be 2. The standard error, so here you see the difference in means. Mu a minus 30 should be 2. Our sigma over square root n should be the same. We assume we have a standard deviation of 4. I just picked 4, so it would cancel out with the square root of 16. So that just gets 2. And then we want the probability, a standard normal is above 1.645 minus 2, so that should be about 64%. Okay. And then in this one, let me just see what the delta equals 2 standard deviation equals 4. At any rate, it does appear to be the same setting, right? Our difference in the means is 2. Our standard deviation is 4. We're doing a one sample test and we're doing one-sided. We have n equals 16 and we get a similar number but not an identical number. But the reason it's not identical is because we're doing power for the t-test here, and in the other case we're doing power for the Gaussian. And then let's also discuss why this power is a little bit lower. Okay. Where did I put? Oh man. Yeah, there we go. Okay. So here, you know, the t distribution is a little bit flatter than the normal distribution, and so what we want is, you know, if we have, like, say, for example, this is here's the distribution under H naught of the standardized statistic, and here's the distribution under HA of the standardized statistic, plotted on the same scale. And here is our rejection region for the t, and here is our rejection region for the Gaussian. And then our t power would be here. So see, it would just be a different number, and our Gaussian power would be here. And notice how I'm drawing it here. It's a little bit hard to see, but the Gaussian power would be 1, whereas the t power would not be exactly 1. Anyway, that's the difference. It's these heavier tails of the t distribution is changing the power, and in this case, it's bringing the power down. Because, you know, just I think you can see exactly why, because of the heavier tails. Anyway, that's the main distinction between those two slides. They're not actually saying the same thing. Okay. Okay. So okay. Let's see. Any other questions from the folks listening? Or hopefully that answered that question. Let's see. Let me double check the forums if anyone posted in the online office hours forum. Okay, no. And then in the statistical inference class, discussion forums. So I'm thinking for the statistical inference class, my understanding right now is that I have the some of these technical glitches fixed. Where was the staff forum? At any rate, there was a couple of discussions of issue with the quiz, and now I'm giving everyone another chance at quiz 1 because of an error. So let's see. Let's see. Okay. Well, if there's no other posted questions, then I think I will end the office hours. Remember, for next week, if you have some questions, please post them to the forum. And well, let me just check. I see. Hang on. Discussion forums. I think, you know what? I am in the. I'm in the wrong section. That's why I'm not seeing anything. Okay. Section 2. Let's see. let's see, I think we discussed the question on the medians, but I will reply. We discussed the question on medians that's coming up in the forums, but I will reply to that on the forum itself because we discussed it in the last office hours. So I think, oh, someone posted quiz confusion in the online forums about quiz 2 questions 4 and 7. Let's see. So Stephanie, I'm assuming, are you talking? Let's see. So you're talking about quiz 2. It's a nightmare navigating this thing. Okay, quiz 2. Okay, question 4 and 7. Quiz 2, questions 4. Okay, so let's just go through this. Questions 4 and 7. All right, oh. How do I do this? All right. What do I want? There we go. Okay, yeah, I think that's what I had up already. Okay, so the question asked about a percentile in question 4, and then let me see if question 7 is similar. This is okay. So question 7 is maybe a little bit harder. Question 4, I think is kind of, oh, quiz 3. Okay. All right. Well, let me answer this non-existent question about what the percentile is. So question 4 of quiz 2 actually asks you what a percentile is. So it specifically asks to find what is the 95th percentile of a specific normal distribution that has a specific mean and a specific standard deviation sigma. Okay. And so what you want is to find the x such that that 95% holds. Any rate, the Q norm, which stands for quantile, in R will just directly calculate that for you. You just need to give it the correct percentile. You need to give it the mean. You need to give it the mean and the standard deviation, and it'll just give you that number. Though make sure you're giving it the 95%, or there's an option where you can give it the upper tail. But it's just easy enough by yourself to subtract. Okay, so let me now check for Stephanie's question, quiz 3. So I gotta go back. Let's see, quiz 3. Quiz 3. Quiz 3, question 4. Okay, so I think, Stephanie, my thinking is probably what's hard about this has nothing to do with the statistics, but with the frustrating way in which I have elected to use Coursera's platform to get an answer. I think what I should do for this is what I'm hoping is that people can get the answer, that they can work out the confidence interval, formula here that says that n was 20 nights and 20 nights, and they randomized 2 groups of these 2 triage systems. Where I'm sorry, not n. The overall n was 20, but let's say n1 was 10 and n2 was 10, and then the waiting time, the average wait or the median waiting time for the new system was 3 hours, with a variance sigma squared of 0.6, and the old system was had a median waiting time. This is for the new, and for the old one was 5, with a variance of 0.68. And it wants it asks for 95% confidence interval. So if you were to do new minus old, okay, then so it's going to be new minus old plus or minus the standard error, times square root 1 over 10 plus 1 over 10. But let me just say at the beginning, this interval is the lower end point at least is going to be negative, because the new is 3 and the old is 5. So you're going to subtract that off, and then you're going to subtract a positive number. So the lower number is going to be negative. The upper number is going to be either positive or less negative. The key to this question is you have to then solve for that and give the two numbers. Let's say they work out to be -2 and -1. You have to give them like that, -2 and -1, with one space in between, in that order. If you do -1 then -2, it's gonna give you the incorrect answer, or it's gonna mark it as incorrect. So that's the problem, and the problem is I would like I would like it to grade those two as equivalent, because the only mistake the person is making between these two answers is that they're failing to recognize that -1 is not a smaller number than -2, but it's quite easy to do that. So at any rate, I tell you, why don't there's been a lot of, I think there's been so much consistent annoyance about these particular kinds of questions that I think maybe I'll just change it to be multiple choice or something like that. I think that's maybe the easiest thing to do, because even the TAs and the folks like that are having are really getting kind of irritated with this auto grading problem from these questions. I'm confident that's what you're talking about for this one. Let me see if 7 has the same problem. Yeah, so 7 is the same thing. So why don't I do this? I'll go through those things and change the question. I'll add a quiz attempt so that people who are dying from doing this over and over again and screwing it up, though actually not screwing up the statistical part, just screwing up the entry part for the Coursera stuff, I'll change that. But it's pretty clear that form of putting in the answer is really quite obnoxious. And I have to admit, even as I was creating the question, I entered in the values wrong a bunch of times, and at any rate, it's not testing anything meaningful. So I'll just change that. Okay, so hopefully that answers that question. So I apologize about all the confusion over those. Just because it's obviously just confusion in how to enter in the question or enter in the response, not confusion conceptually. It seems like people are conceptually getting the problem right. Okay, so I'll give everyone another second to answer some questions, or to ask some questions, but I guess if there's no new QA questions, what I will do is end the office hours, and I'll then just spend the next couple minutes making that change. All right, so looks like I don't see anything. So thanks everyone for attending the office hour, and I will hopefully see you guys next week.